Thunder, congrats on another first. Thank you for the wishes. In course lays. Hello? I feel like that fortune is not entirely true. I feel like some people's reputations just seem to be unbreakable, but hope you're doing well. He's probably gonna be a little hot. Okay. Actually, what's the count for first looking like these days? Oh, you know what? I know why my shift key isn't working like normal. That's better. That's gonna mess me up. Oh man, that feels... No, that doesn't feel right. So the issue is my keyboard... my shift key kind of randomly stopped working. And it's because my keyboard has... One of the keys on it changes like the activation point for the keys, and I accidentally bumped that button. I think that's where I had it. I don't remember though. Anyway, Thunder... Oh, you're not quite on the leaderboard yet. Tunda. 20. You're not too far out. Just need to get probably 10 more, and then you'll be number 5. Okay, so... Is the music... Ooh, no, it's still too hot. The song is all over the place with its volume. It should be better. Okay. So I want to start off with some more mathematical oncology type of stuff, just because I really do need to get on this project. This quarter's flying by. For my cancer modeling class, we have to do a final project where we take a research paper and modify it in some way. And I've done slightly more than 0 work on that. So I've looked kind of at this paper a little bit before, but I want to because I want to look at the equations that we just scrolled past. Actually, wait. No, maybe before we do that, let's see if we can find where they identify like deficiencies in their work. Zach, thank you for the raid. I saw you talking about randomness, and that's always a really fun thing to talk about. Hey Fembucks and hey Rex, thank you for the wishes. Hey Obi. Always do right. This will gratify some people and astonish the rest. That's a decent quote. Maya Stellar, thank you. Welcome in. So what's on the docket for today? I was going to start off by reading through some that was a great thing from The Office. Do left. Yeah, don't do right, do left. Thank you, E to the 2I AI. Also, have you figured out what you're going to talk about in 3 hours, Zach? Absolutely, Fenbox, yeah. Distract away. Until Fenbox fully... You haven't the foggiest? I don't know how you do that, Zach. I'm the complete opposite. If I don't plan it out, I'm gonna have nothing to say, and then I'm gonna get on Shane's stream and be like, I'm still gonna be like that, but I'll be less like that. Hey WW, welcome in. So yeah, until someone distracts me, the plan for the start of this stream is to read through some papers on mathematical oncology, which is like studying cancer through math. So I need to do a project for one of my classes, and that involves like taking an existing research paper and modifying it. So I'm trying to get ideas for that. For 1,300 hours on Twitch this way, you think? Yeah, I mean that's very true, Zach. Yeah, I personally could not do that, but you definitely could. Like you and Shane could just like talk about random stuff, and it'd be a really fun time. So you guys both like think a lot about like teaching and like I guess like pedagogy. That's the better word. Your talking points with Dr. Golding still felt underprepared. That got back into grinding beans. I'm wondering about different machines. I have a blade grinder. I've heard that burr grinders. Yes. Blade grinders are like, you can get better results with them if you like make sure to like shake them as you're grinding and like to make sure like things get distributed. But they're going to give you really inconsistent grind sizes, and that matters less the darker the roast of coffee that you're drinking. But it's still, you should see a pretty big difference if you go to a metal burr grinder. Don't do ceramic burrs. Like ceramic burrs suck, and you may as well just stick with the blade grinder. Oh, for light roast, yeah, you 100% want a better grinder. Thank you, Joseph. So, it's a little on the like expensive side, unfortunately, but like the Baratza Encore is the first coffee grinder that I got, and it's a really solid like universal entry level choice. I think there's a more updated one than this, but $150, and this grinder is it'll get you most of the way. It'll give you most of what expensive grinders give you. Like 80% or something. I can't talk. I want to say that there's been you can probably find a, like, because when I first bought this was really the only entry level grinder also that was even worth it. There may have been other grinders that have been added since. I don't know if any are like quite at like $150 though. They're gonna be more like 200 or more usually. And like I really like this company too because they're big into like being repairable. Like they have really good videos about disassembling, like teaching you how to disassemble the grinder. They sell all the spare parts individually. I've contacted the customer service like I think I was asking when like some spare part would be back in stock, and they sent me the thing for free. So I really like the company too. You have a hand cranked burr grinder. Ooh, that's cool, Obi. Crush the beans with your fist. Yeah. They're consistent until they decide to shoot your Hamilton's true. Ceramic burrs kicked my puppy. They did. So yeah, Baratza did get bought out by Breville. I think they haven't changed much, but I haven't interacted with them since they got bought out. Yeah, and so you can buy them through like usually like there's a list somewhere on their website. Actually, let me just like drop this link. There should be a list somewhere on the website of where all their local distributors are. And I bet there's a coffee roaster by you that just sells them, and you could go and like pick it up if you wanted. That's how I got mine. And so, yeah, it is a little bit loud. It is an electric grinder. Oh yeah, I forgot to mention that. One of the main gripes with them is that they can be a little loud. I never minded personally, but most electric grinders are going to make a good amount of noise. If you want to go for hand grinding, then that's decently quiet. But hand grinding's a pain in the ass, so thank you, Jed. Yeah, no worries. That part of the song is kind of weird. What's your name? Who's your daddy? Yeah, and so like they sell like upgraded burrs that give you better like grind profile too, and so I eventually put those into my encore. And so yeah, it's a nice thing. So yeah, I'll stop rambling. 70s sensibilities? Yeah, I guess. Okay. Um, I guess we'll go back to reading through this paper, unless someone wants to distract me again, which is always welcome. Okay, so I wanted to look at this quick guide to model and major assumptions. This is the part of the paper that I actually wait. No. I forgot. I wanted to look like where do they identify future work? It's usually towards the end of papers. Oh my god, there's so many words. Okay, you know what? Control F, future. Really? Okay, well. Thank you, Clonk. Oh, this is it's kind of funny seeing an academic paper. This feels like an opinion. We strongly believe future precision medicine. In the smarter evolutionary enlightened application of pre-existing ones. That's a weird way to say something. The will of the people is the best law. Ooh, the fortune cookies are getting political. Hey, Maya. That makes you think of the Monty Python skit where like oh my god, like strange women distributing swords is no basis for a system of government. Just reminds you of like that whole bit. So Maya, I guess for background, I'm an applied math master's student. One of the classes I'm currently taking is a class in cancer modeling, and the final project for that class is basically going to have us take an academic paper, modify it in some way, and try to do something new and interesting. Hopefully. And so I'm looking through papers and trying to figure out what interests me and what potential ideas I can come up with. And questions are welcome at any time, either about what I'm doing or completely random questions from anything, I guess. So yeah, this paper is about spatial heterogeneity and evolutionary dynamics modulate time to recurrence, the words. How many papers have I read so far? I mean, I've skimmed through like 2 or 3. I'm really behind on like uh reading these papers. Do I know what a tensor is? I know they're vaguely something like a matrix, but in like more dimensions, I guess. Like instead of a like your normal matrix is either like just a single vector or it's a vector of vectors, and a tensor could be like a vector of vectors. That's about it though. If I said I remember because some moistened bent lopped scimitar at me, I'd be taken away. Paper contains some kind of mathematical argument that supports that claim. Treatments like these can be up to 10% more effective. The summary at the end says we strongly believe. Yeah, that sentence really strikes me as not scientific. Like it's interesting that a peer-reviewed paper would have a sentence like that. It's probably better to. I have read the abstract once, but I should read it again. 3 chapters of Grinfield's tensor calc. Okay, yeah, I really need to learn like matrix calc and tensors and stuff like that. Treatment of advanced cancers benefited from new agents that supplement or bypass conventional therapies. Even effective therapies fail as cancer cells deploy a wide range of resistance strategies. We propose evolutionary dynamics ultimately determine survival and proliferation of resistant cells. Evolutionary strategies should be used with conventional therapies to delay or prevent resistance. So yeah, it's a common issue with treating cancer that like cancer multiplies so quickly that it accumulates a lot of random mutations, and just through sheer like random chance, there often be a very small number of cells in a tumor that have already mutated resistance to whatever drug you're going to use to try and combat it just by chance. And so even if your drug wipes out like 99% of the tumor, that last 1% or even less that survives is just going to come right back and multiply, and the drug won't work on those cells. Well, yeah, I guess it's the thriving part that is really the issue there, $10. Oh yeah, Max. I thought you were asking like I assumed that you already knew what a tensor was and that you were just wondering if I also knew. But yeah, if you're asking me to describe what a tensor is, I'm not really able to do that, unfortunately. Like look at the Wikipedia page, but I've never used a tensor to do anything. I was completing your freshmore year. Had advanced calc in semester 1. This semester we had probability and stats. End semester in a week. 40% weightage. Ooh. Well, good luck. You're almost there. Probability and stats, it's challenging, but it's really cool. And I'm using a lot of it for this cancer modeling stuff. Like it's really like everything that we're doing is like a stochastic process. Using an agent-based framework to model spatial competition among sensitive and resistant populations, we applied anti-proliferative drug treatments to varying ratios of sensitive and resistant cells. We compared a continuous maximum tolerated dose schedule, an adaptive schedule aimed at tumor control via competition between sensitive and resistant cells. Continuous treatment cured mostly sensitive tumors, but with any resistant cells recurrence was inevitable. We had identified 2 adaptive strategies that control heterogeneous tumors. Dose modulation controls most tumors with less drug. Well, a more vacation-oriented schedule can control more invasive tumors. What is a vacation-oriented schedule? Aruba, Jamaica. These findings offer potential modifications to treatment regimens that may improve outcomes and reduce resistance and recurrence. So, hey, color cone. How I'm interpreting this is if you just go up to the maximum dose immediately, you wipe out all of the sensitive cells and leave all the resistant cells. But if you don't go to the maximum dose, leaving some of the sensitive cells alive, they will be in competition with the resistant cells and help contain, I guess, control the resistant cells. You're probably not going to wipe them out, but the sensitive and resistant cells are competing for the same resources. So if you just wipe out the sensitive cells, or the resistant cells will take over. Everybody's working for the weekend. Okay, so now let's read this part. Okay, off-lattice agent-based model. We use an off-lattice agent-based model to investigate the spatial evolutionary dynamics of differential treatment schedules on heterogeneous tumors. What is an off-lattice agent-based model? Who cares? Space is the limiting factor, such that at carrying capacity, a cell will enter quiescence due to contact with inhibition, or due to contact inhibition. I think quiescence is it stops dividing. Space is deemed available if any contiguous set of integer angles is empty, insufficient to allow a cell to fit without overlap. When a cell is quiescent, we assume it cannot proliferate and is not affected by the drug. Oh, there we go. I'll assume there's no cell death due to regular turnover. Resources are abundant when cell densities are below carrying capacity. Okay, then they have a flow chart. We probably should look at that if we get into this paper more. We should see 100 cells in 2 configurations, randomly scattered throughout 1.5 millimeter radius circular domain, in vitro cell culture distribution. 2 hours into your Baldur's Gate 3 stream, they're going to see you didn't have the sound, turn on the sound to VOD option. Oh no! Do you split your audio too? No, color cone. I haven't made very much progress. I went to office hours on Thursday after I streamed. And one of the questions other students asked about, I had already done. And then the other question they asked about was this one number 5 here. But the way that the TA was doing it was kind of... Where am I? Oh, I took notes by hand for once. The way the TA was doing it was kind of... I think not necessary. I think there should be a simpler way. So at some point in the stream, I'm going to get to PDEs, but... I think this problem here shouldn't be that hard. It's just kind of finding the right combination of... Or like just finding the right definition for the function to work with. Chatting for 2 hours with visuals in the background. I've done that. No. I wish I had the opportunity to teach or TA, but I do not. I'm only a student. I'm saying I went to the TA's office hours for this other class that I'm in for partial differential equations. But yeah, this homework is pretty freaking cooked. It gets really weird. Like, these last 3 problems are kind of scary. And this is like a mega homework too, because the lecture's been canceled for this class all this week and on Monday. And rather than giving us a break, he assigned twice as much homework. So that's fun. Like, the normal pace is like, it's not, I guess extra homework is a little bit harsh, but like, he always assigns 5 problems per week for homework, and then this homework is 10 problems over 2 weeks, so it's still the same pace, but like we're not going to lecture. I wish he just assigned 5 problems like normal and just gave us 2 weeks to do it. But oh well. So representing in vitro cell culture distribution, tightly clustered in the center, representing a dense tumor mass. Started with 100 cells to keep the initial population small, but also large enough to capture sufficiently diverse pre-existing distribution of phenotypes. When these were grown with 2 distinct sensitive resistant phenotypes, we used the average cell cycle times for the sensitive resistant cells found at the beginning of the in vitro experiment. I don't know what these mean. The heterogeneous tumors, the initial distribution of phenotypes varied and was reported. Simulation was stopped when the number of cells reached 15,000, which is around 1.5 millimeter in diameter when grown as a dense mass. Okay. Treatment. For continuous therapy, we applied the MTD. Surely they did say what MTD is somewhere in this paper. Here's another MTD. Oh, maximum tolerated dose. There we go. We applied the MTD the entire duration. Only if cells capable of dividing does it become sensitive to drug toxicity. For adaptive therapy, that's kind of an interesting constraint. I assume there's a biological reason that that's true. For adaptive therapy, each dose was instantaneously effective. Really? Ignoring any short-term pharmacokinetics. Why? Why would we do two different things for the different the different therapies? Regardless of the treatment schedule, a cell's response to drug exposure was defined as the probability of death, p-death, which depends on its sensitivity S and the dose D. D is value from 0 to 1. What is S? Due to resistance cost, we assigned the cells with the shortest cycle. Resistance cost. We assign the cells with the shortest cycle times T-min 100% sensitivity. In a linear fashion, long cycle times T-max. It's completely resistance. Are they saying resistant cells replicate slower? Or divide slower? Is that what resistance cost is? I mean, maybe Carla Cone. That'd be kind of cool. Okay, so I guess they're saying that resistance mutations make you divide slower, which isn't always true, I don't think. It's usually... Yeah, I don't know. Day of tomorrow is physics exam, so I was studying for it. Circuit problems involving Norton, Thevenin, and electromagnetism. Ooh, that's cool. I love me some E&M. So what is this S of T? Is sensitivity. And sensitivity depends on cycle time. Okay. And then we're taking the dose. Oh, this is a Michaelis-Menten equation, I think. Yeah, Hill coefficient. So we're taking the dose, dividing it by dose plus Hill coefficient. Did we divide slower and you're worried about survival? That's true. The microwave equation? No. Michaelis-Menten kinetics. Close enough. This looks a little bit different, but it's basically this. It's a differential equation that describes... something. It's like a one-way reaction rate, I think. It might be Michaelis, I don't know. But I think when you have an enzyme facilitating some chemical or biological action, the rate that that thing is turned into, that thing follows this curve. Rotten C. Hymicus, thank you for the wishes. Welcome in. So they get too messy in exams at any given time becomes difficult to solve correctly. Yeah, circuits can get kind of crazy. Benvox is really good with them. Vic Michaelis on Dropout TV. Oh, I don't know what Dropout TV is. Oops, that's not the paper. Okay, this provides a simple linear trade-off between... Oh, College Humor. Okay, okay. They changed names? I didn't know that. Provides a simple linear trade-off between a cell's fitness in the absence and presence of drug. We use a Hill function to describe the dose effect, setting the coefficient half maximal activity. N equals 1.5 and k.5 equals 0.25. These odds are not specific, but generically assume a response function that gives nearly 100% probability of death at the highest drug concentrations, dropping off slowly at the mid-ranges, then quicker as it gets to lower concentrations. Okay. The dose varies from its previous value d naught based on the relationship of the current number of cells n. The previous number of cells n naught. The dose varies from its previous value d naught. Okay. So D, we don't administer any drug at all if the current number of cells is less than half of the starting number of cells. We increase the dose if the number of cells has increased by some percent. Like, or we increase the dose by some percent if the number of cells is increased by some other percent. We decrease the dose if the number of cells has decreased some percent, but not if it's lower than 50. Or we maintain the dose otherwise. Well, what is the otherwise case? Isn't this all the cases already? Oh wait, no. There's like a middle ground between these two cases. Okay. Taught by Sam Reich, son of Robert, Department of Labor Secretary during Clinton admin. Oh, that's random. Alpha beta are fixed size. I assume alpha beta are between 0 and 1. How much the dose changes due to population size changes. And equation B, if the number of cells is below half the original. A treatment vacation occurs. We're going on vacation. Okay, so that's what they mean by vacation, when there's no treatment at all. Or no, like, dosage. Oh, I already figured this part out. Okay, well, fair enough. Dose always begins at the maximum tolerated dose, never exceeds the maximum tolerated dose. Each new dose was determined every 3 days in accordance with the experiments reported for 13. So this is like an iterated equation. Like D naught is changing every 3 days. Which feels a little like, I feel like there should be they should use some subscript T's here instead of D and D naught, but this still works. If a cell was killed by the drug, there is a 15 to 30 hour delay randomly chosen before it is removed from the domain to account for the time it takes for apoptosis to occur. Treatment is stopped when either the tumor is cured, number of current cells is 0, recurs when it gets to 4/3 of its original population. Why would you stop treatment? Isn't that when you need treatment the most? Don't we start with 100 cells? 100 times 4/3 is not 20,000. I don't know where that 20,000 number comes from. Or the tumor reach an age of 2 years after treatment. I assume that's reflecting ineffective treatment. We assume tumor control is... We assume tumor control if the final number of cells is below 10,000. Half the value that determines the recurrence and accounts for fluctuations during adaptive treatments. Okay. To examine cell migration, we assumed all cells move in a persistent random walk as follows. The idea that cells can migrate is kind of wild to me. I don't know how that works. They don't have legs. But okay. Each cell is given a random angle of movement and persistence time, during which it moved in a straight line at 5 micrometers per hour. After this time, it turned at a random angle, started again with a new persistence time. Cells migrated in this way as long as they were not in the quiescent state, did not contact another cell. Contact cells turned by random angle, started again with a new persistence time. They said earlier it's 15,000? Do I not know how to read? Oh, hey, you're right. Oh, the final... Right. Okay. That's the They do start with 100, but the simulation is stopped when the number of cells reach 15,000. Well, then how do you ever reach 20,000? I don't know. I'm still a little confused by what they're actually saying here, then. I think that must be where it comes from, because you're right that 20,000 is 4/3 of 15,000. And this it is a moving target. That's why I hate this notation, actually. Because this should be just initial population in my mind at time 0, because they have a 0. Like, if that was n sub t, this would be a bit more clear to me. But even then, I'm still confused by how that's consistent with this statement here, that they stopped the simulation at 15,000. But this is kind of a cool thing they're still doing, though. We examine phenotypic drift by allowing daughter cells to inherit a slightly different proliferation rate upon division. Winklebot. Hello. At each division, there's a 10% probability the self-proliferation rate could change by randomly choosing one of 3 options: increase its cycle time by 1 hour, decrease cycle time by 1 hour, or stay the same. The other 9% of the time, proliferation rate stayed the same. Isn't that redundant with the third possibility? Can I ask problem in your Calc 2? I'm excited to see you streaming. Oh, okay. Yeah, that series that you hit me with a while ago it's kind of crazy. I can only imagine what you're dealing with now. They had 2 different methods of growing a sample of 15,000 cells. True. Oh, this is just setting the stage, is what you mean. Okay, yeah, and then that's when they start treatment. That would make sense. You let the tumor grow first before you start treatment. Okay. Yeah, WW. I think you figured it out. Texas throwing temptation at me that I've never seen. Yeah, sure. Okay, so it's kind of cool with like the random walks that are happening. I wonder what the purpose of the movement is, though, because when they bump into each other, I don't think anything special happens. Maybe let's... What'll be an interesting thing to scroll down to in this paper? Maybe results. Fitness differences in space limitations affect competition and selection. The cost of resistance in the selection force imposed by competition space limitations. I guess that the movement encodes competition and space limitations. Can be demonstrated through a combination of in vitro and in silico models. In silico is such a silly phrase to me, but fair enough. For the in vitro experiment, the MCF7 DOX cell line was used, which is highly resistant to many chemotherapy agents due to upregulation of the membrane efflux pump P glycoprotein. This feels like a sci-fi thing. The upregulation of the membrane efflux pump P glycoprotein or multiple drug resistance MDR1 proteins. When plated in the absence of chemotherapy, doxorubicin in the media, the MCF7 DOX cell line was observed to grow much slower than the parental MCF7 line. Initial doubling times were 40 hours, MCF DOX was 60 hours. When co-cultured, the sensitive MCF7 cells rapidly outcompeted the resistant MCF7 DOX line after only a few generations. So I guess that I assume this therapy can only work if you divide slower when you gain resistance. I always imagine this wouldn't be very effective. I see Winklebot posted the question though. Oh, okay. Yeah, yeah. We can talk about this. Ah. I'm messing things up. 1 minute. Okay. Getting radius of 0. My solution sheet for this one says the radius is 2. A radius of convergence? Oh, okay. I missed it. There's an X there. I was about to. Oh yeah. So you could say it like that. As a falling factorial, I think they're called. Let me read what you're interpreting it as first, though. Never encountered notation like this before. My text was just confusing. I think they're trying to imply we multiply sequence 2k plus 1 by 2k minus 1. I'm not sure what you mean by that, to be honest. But what this thing in the denominator means, it's like a factorial, but only what you only do odd numbers. It's the same thing as what's on the screen, I guess. So, like, a regular... So, normal if you have k factorial, you do k times k minus 1 times k minus 2, etc. Down to, like, times 2 times 1. But when we do this, it means we're striking out, like, every other number. We don't have a very good notation for it. Like, I'm not a fan of the double factorial thing. And so we tend to just write out the actual pattern and let you kind of infer that it's like a factorial, but not exactly a factorial. So it's just saying it's a factorial, but for every odd number up to 2k plus 1. So you start off with like 1 times 3 times, or you start off with, like, for k equals 1, this number here is 1. So you just have, but you know, let's just make a chart. 1 times 3 times 5, 2k minus 1. So when k equals 1, this is just 1. When k equals 2, this is 1 times 3. When k equals 3, it's 1 times 3 times 5 times 4, 1 times 3 times 5 times 7. So it's just every odd number. So another way you could, well, never mind. So you could think of it as almost like 8 factorial, but you slash away all the even numbers. Or 7 factorial, I mean. Yeah, so the only notation that's commonly used to express stuff like this is a double factorial, or it's called like a falling factorial, which is what Zach was writing in chat. I hate this though because it's confusing with like k factorial, which is completely different. So we often just use the notation that's like in the problem that was provided. And yeah, Zach sees the idea. I mean, that's true, but like, it's yeah. And so Zach is pointing out there's actually a cancellation here. And you're seeing it now, it seems like. Yeah, so even before we apply the ratio test, we can still do this cancellation. But honestly, if you're confused by it, you could just go straight to the ratio test. Yeah, I'm trying to figure out like how the cancellation actually works. I think there's gonna be they're not quite the same, Jed, are they? For the reason that you're saying. If k, well, wait. If k equals 4, yeah, so it's a little bit weird. Like, I want to write out, if we have 4 factorial over 1 times 3 times 5 times 7, only the first few terms are going to cancel. So while we could, in theory, simplify this fraction right here a little bit, you're probably better off not doing it because it's going to make it messier. And I would just go straight to the ratio test here. And I think that's what you were saying anyway, Winklebot. So for the ratio, wait, not x, n. K. So k plus 1 factorial over 1 times 3 times 5 dot 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 2k plus 1 minus 1 times x to the k plus 1 divided by k factorial 1 times 3 times 5 2k minus 1 x to the k. Okay. RLC of 0 seems correct without formally checking. Let's see if we can have an opinion on this. So the absolute value bars, like this stuff over here is always positive, so it doesn't care about the absolute value bars. This k plus 1 factorial cancels with the k factorial. We have just a k plus 1 left over in the numerator. Now this cancellation here is a little bit tricky, and we should write it out separately, I think. We have 1 times 3 times 5 times 2k minus 1. 1 times 3 times 5. And so 2k plus 1 minus 1 is 2k plus 2 minus 1. So that's 2k plus 1. Okay, that's not so bad. So for this, Yeah, Zach. That's what Jed was saying, basically. They don't fully cancel. I'm a moron too. We can be morons together. Um, so I know the number before 2k plus 1 in this pattern is 2k minus 1. And the reason that that's true is because these numbers are moving by 2 each time. So if I want to start at the end and move backwards, I take 2k plus 1 and subtract 2 off, and that's 2k minus 1. And then, oh look, happy days. These are the exact same thing. So they can cancel. So we end up with a 2k plus 1 in the denominator. Then these x's can cancel to be just an x. Absolute value. And then using limit tricks on this, it's linear on top, linear on the bottom. So the limit is this coefficient of 1 divided by this coefficient of 2. So it's 1/2 x, and we require it to be less than 1. So the radius of convergence is indeed 2. So yeah, I hope that makes sense. Let me know if I lost you anywhere. It is a good thing to just kind of get used to patterns like that. Because they do kind of keep coming up. And if you want to really have fun, you can start doing things like taking the factorial of 1/2, which is square root pi. Yeah, the notation can be a lot. The notation method, it only gets worse, unfortunately. It never gets better. Yeah, yeah. Um, you were close. uh, no worries. Hey, thank you for the question, Winklebot. And yeah, no, notation in math is so terrible. I like it's just hard. Like, and the worst part is I don't even have a better suggestion most of the time. It's just difficult to figure out how to express these ideas. Oh, delta sub or like d sub x for partial derivatives. I'm not a fan of that either. Derivatives notation gets so confusing once you start using like the big D notation. Yeah, exactly, Winklebot. Yeah, Zach, like like because like in full generality, you can have like D like just a normal D is just like implied to be like the gradient, and like D2 is the Hessian. But like for the notation in general, you could have like D like 1 comma 2 comma 5 comma 3, or like it can be a string of numbers that denote different derivatives. Like I've never actually seen it get used, but like uh and I'm sure you already know this, but I want to like rant about it. Wait, so in this. Yeah, this section right here. Where alpha is a multi-index, because they can't just call it a vector. Actually, wait, is it this one? Do I need to scroll up a little bit? Oh, here. This is where they say multi-index notation. Yeah, so you could have like, I don't know when you ever need this, but like you could have, say like, oh, I want the first partial derivative for x1 and the 50th partial derivative for x3 all in the same set. God, yeah, you have to mathematically flex. That's when you need it. Every paper ever, dude. Oh my God. Oh no. Oh, you're making me think of what my PDEs professor has done a few times in class. He has flexed. What is it called? Dyadic summation. Not diabetes. Diabetic summation. I don't know how you spell it. Let me see if I can find it in my notes. It's a way that it's a trick he used to evaluate an integral, and I hate it. It's the worst thing he's done in class ever, because it's, in one case he did it just to like prove a student wrong, that it's like he suggested using a U sub, and he didn't want to do, and a U sub is apparently just like below him, and he didn't want to do it, so he did it a complicated way that I did not understand. Okay. I think I found it. We had, this was for the fundamental solution to Laplace's equation in 2 dimensions, is where the context this came up in. We had the integral from 0 to epsilon log r rdr. And this is the integral specifically, like you could just do it with a U sub, I think. Or like you definitely don't need this, but he made it a sum from L equals log of 1 over epsilon to infinity of 2 to the minus L. My notes are a little bit messy, so that might be slightly off. Oh wait, 2 to the L minus 1, I think. To 2 to the minus L. Log y dy. Oh. And this is apparently equal to the sum L equals log 1 over epsilon to infinity 2 to the minus L log 2 to the minus L 2 to the minus L? I have no clue. Oh wait, there's an approximately. I was writing down the exact thing that I have written in my notes. I don't understand any of this. Two to the dude. What is this? This is the last line. He wanted to prove something about how this solution scales, I guess. I guess this integral is more like an integration by parts thing, I think. But like, yeah. Oh wait, dyadic intervals? I mean, dyadic intervals. Oh, it's with a Y. It's p-adic but 2? Whatever that means. 2-adic is dyadic. Oh, okay. So yeah, I have no clue, but PDEs is difficult enough without doing needlessly complicated integration techniques. Okay. We'll probably go back to looking through the papers, or at least that one paper. But I'll probably switch actually to PD's homework in a few minutes. Where was I? Right, when co-culture, the sensitive cells outcompete the resistant cells, which is really important. Clearly illustrates cost to resistance. Actually, figure 2. Where is figure 2? So it's fun to have this scavenger hunt for where figures are. Okay, top left. So yeah, in vitro, MCF7, which is sensitive, compose most of the cells in there. Appreciates cost resistance. We then investigate these evolutionary dynamics through our computational model systems using the same initial cell cycle times for sensitive and resistant cells. In the in vitro experiment, using both scattered distribution analogous to the in vitro setting and a more cluster distribution analogous to the more in vivo setting. Oh wait, what's in vitro versus in vivo? Is in vitro in a dish and in vivo in a living patient? I think so. With the scattered distribution, we observed. I'm getting bored. Proliferation. Start skimming again. Since vitro is often used binary, where a cell that is exposed to drugs simply dies if sensitive or survives as resistance. Turns to have a more nuanced mix of phenotypes. We investigate how various mixture sensitive and resistant cells compete to form a solid tumor mass. Views in the bodies in real life. Okay. Yeah, that's my understanding too. WW. At least for in vitro and in silico. A scientist, you concur that, well, you have scientists in your name, so that's good enough for me. Welcome in. Said how various mixtures of sensitive resistant cells compete to form a solid tumor mass, starting with cell cycle times randomly drawn from a normal distribution, mean and standard deviation. More cells got trapped in the interior tumor by more sensitive cells, which took over the invading edge. Coexistence between different phenotypes was seen. Given enough time, the more proliferative phenotype should take over the invading edge. Sure. Faster proliferators will dominate the population. Timing depends on the relative fitness differences. Makes sense? Continuous treatments can cure some tumors. Adaptive treatments can control most tumors. I wonder what what controlling does. Like, that's more positive of an outcome than letting them go out of control, I guess. But the difference between curing and controlling is kind of big. um, do you net of scheme that changes the dose by 25% if the population size changed by 5%? Like, I wonder what the patient outcomes are for a controlled tumor. Like, I don't know. Then there's not one therapy strategy that works best for all tumors. A response to the treatment dependent on the tumor composition. The most sensitive and homogeneous tumor, CT continuous treatment killed the tumor completely, while... Oh my god, wait, how have I already forgotten? Adaptive treatment kept the tumor under control using an average dose of 34% of the maximum tolerated dose. Well, dose for adaptive treatment was about 2 times, the total dose was about 2 times that of CT, so distributed over a time period about 6 times as long. Huh. The tumor consisting primarily of sensitive cells, but with some tumor-resistant phenotypes. Initially responded very well to CT. This was followed by recurrence of a complete resistant population after about 1 year. That's to be expected. The same tumor under the adaptive treatment could be controlled with an average of only 35% of the maximum tolerated dose. The total dose that was 70% of that given using CT. Same tumor for the average. Huh. I guess if curing isn't an option, that's when you would want to control. The more resistant tumor should yield a slight net negative growth rate with the MTD applied. However, after a modest initial response to CT treatment, resistant cells took over enough to yield a positive net growth rate, which led to tumor progression. Using the AT strategy, the change in population was too slow to induce dose modulation. Really? Huh. When the population had that around 1 year, treatment vacation was applied. Despite most sensitive cells had already been eliminated, the tumor was spatially diffuse. Consequently, a large portion of actively proliferating cells quickly expanded. Tumor occurred 1 month prior than using the CT strategy. So that's, I guess, not good. For the more resistant heterogeneous tumor, both treatments led to eventual recurrence. Total number of cells was kept stable for a while using AT. Is this all that helpful then? I don't know. Well, let's kind of go down. So results or discussion. I just passed by discussion. Was I in results? I probably was. So let's look at discussion instead. I want to know what their conclusions are. Our simulations demonstrate the necessity of matching any cancer treatment regimen to the corresponding intratumoral evolutionary dynamics. The term precision medicine is often applied to strategies to match tumor treatment with predictive biomarkers. This approach increases the probability of success and neglects the reality that virtually all tumor responses are followed by evolution of resistance and thus treatment failure. Our results indicate that precision medicine also needs to encompass the complex evolutionary dynamics that govern emergence and proliferation of resistant phenotypes, present the diverse Darwinian interactions that can lead to resistance, but also corresponding treatment strategies that can exploit these dynamics to delay the time to progression. It is clear from our analysis there is no one-size-fits-all evolutionary strategy. Using a modified off-lattice agent-based model, we found conventional MTD application of cancer therapy can cure homogeneous tumors that consist entirely or almost entirely of cells that are sensitive to the applied treatment. Yeah, there has been, I seeded it with a Writers on the Storm, so it makes sense if it's kind of doors heavy. I'm glad it's not Coldplay heavy, like it usually is. Um, using a modified off-lattice agent. Ah, dude, okay. We found conventional MTD application of cancer therapy can cure homogeneous tumors. This is entirely almost cells that are sensitive to the applied treatment. While it's improbable at advanced stages, it observed clinically at some tumors that histologically appear homogeneous. There's testicular cancer or some lymphomas, frequently cured by conventional chemotherapy. Histologically, what does that mean? Cambridge. Relating to the science that is concerned with the structure and cell tissue at the microscopic level. Okay. What is the root for that word, actually? Try to Google, like, etymology. Histo. Medical word forming element. Greek histos, warp, web. Anything set up right. Huh. Medical word forming element. Medical writers is the best Greek root which to form terminology for tissue, structural element of the animal body. I guess so. Histo is tissue. All right. Fine. Decades of clinical experience consistent with our model predictions have found that cure is not typically achievable in cancers that are highly heterogeneous. Melanoma, lung, and breast. Because they already contain cells that are therapy resistant due to genetic, epigenetic, or phenotypic properties or environmentally mediated mechanisms. Yeah, Pink Floyd. Tumors are not cured by standard MTD therapy. Okay, so this is like a lot, like it's more of a last resort if you can't do standard therapy. Our models found that evolution-based strategies that exploit the fitness cost of resistance can delay treatment failure and tumor progression. Recent experimental studies have shown that adaptive therapy can enforce prolonged tumor control. However, none of the prior theoretical models have included spatial dynamics. Assume that different tumor subpopulations are well mixed. This in contrast to radiologic and pathologic images of tumor that show marked spatial heterogeneity. This structure can affect the emergence of resistant phenotypes due to space limitations, limited drug perfusion. Since some insight into how spatial context may influence disease control. Reflects similar ideas presented in a recent study with growing bacterial colonies. Okay. Let's see what WW is saying. Reading paper just now from Google. What they're saying is, in a nutshell, if tumor has only sensitive cells, can use treatment at high dose is the best option because it can get rid of the tumor completely. In the case where tumor is most sensitive with some resistant cells, a constant high dose treatment yields a lot worse. Yeah, I think I like just as you read that, I got to the sentence that explained that. And so that helps put this in context for me. Like I wish I read that first. Because this strategy seems like a lot of work, too. Because they're similar with both treatment strategies. Dynamics for treatment modulation failed with the other one because the dynamics didn't even activate. Okay, that makes sense. So let's see if they point out like for themselves potential future work. That's the last thing I'm interested in with this paper, I think. So I'm not sure what, like, on my own, what I would add to this paper. Just skimming, looking for something that's talking about downfalls or future work. Okay, greatly simplified, abstracted to study the impact of spatial intratumoral heterogeneity on tumor progression, how it might be treated with adaptive therapy. We've ignored pharmacokinetics, spatially weighted dose dependence. Ooh, microenvironmental influence, therapy-induced drug resistance. Ooh, okay, that's a potential thing to add in here. That wouldn't be that difficult, probably. And of course, the third dimension. Would that... Huh. Could that have a significant effect, adding another dimension? I know random walks change greatly in the third dimension. So maybe I could see there being something different. Huh. It's a possible extension of this work. The model can be modified to represent specific cancers, resistance mechanisms, associated biomarkers. We've chosen a simple starting point to understand how a spectrum of cell phenotypes compete for space under different drug strategies. So I think, like, for drug-induced resistance, we could come back up here. Eventually, I'll get back up here. Here. You could potentially just modify this S of t function. Capital T is just the turnover time for the cell. We can make this a function of... I guess of D. And make it be able to... Like, of T and D, I mean. I'm not sure exactly how it should depend on D. But to, like, talk about drug-induced resistance. Okay, let me catch up with chat. The cells grew so slowly, the equation didn't change the dosage based on the rate of growth in one of the 4 cases. Okay, I think I, like, briefly saw that case. That makes sense. I watched a documentary recently about targeted chemotherapy. It was really interesting, but the doc had been filmed over a full decade. Wow. Can we still manage to get through all the clinical trials needed to get the drug to market? So much money involved and so much time. 10 years isn't enough. That's wild. I wonder how they even, like, how do you make money and, like, stay afloat when it's that long? I guess grants, probably. You know what? So the papers that I had, like, queued up for today were like suggestions from my professor. I am also signed up for... Oh, apparently Canvas is no longer hacked. That's good to know. I'll be able to actually access my homework. I'm also signed up for a Mathematical Oncology, like, newsletter where they talk about recent publications. And one of those papers seems kind of interesting. I want to... see if I can find it. I'm looking at my phone right now. You need grants, you need to find investors that will back you. That's fair. Oh, wait, it wasn't in this email. I'm trying to find out my phone. Yes, okay. I don't know if we will actually see the paper. Quantifying immune memory in colorectal cancer using fractional order derivative differential equations is what caught my eye. Because I thought fractional derivatives were just kind of a meme that people defined for fun. But apparently, fractional derivatives have a use. I just wanted to see if they talk about that. Fractional order differential equation models developed to quantify non-Markovian immune therapy or immune memory effects, T cell exhaustion, MDSC accumulation, and colorectal cancer. Patient-specific fractional orders using transcriptomic signatures. Okay. Fractional order differential equations provide a natural mathematical framework for systems with memory, long-range temporal correlations, or power law relaxation dynamics. In contrast to integer order derivatives that capture local instantaneous rates of change, fractional derivatives of order between 0 and 1 incorporate weighted distributions from the entire history of the function through a power law memory kernel. Huh. This mathematical structure makes fractional calculus particularly well suited for describing biological processes characterized by distributed relaxation times, anomalous diffusion, or persistent states arising from complex underlying mechanisms. Fractional derivatives in biology have spanned diverse phenomena, including viscoelastic tissue mechanics, pharmacokinetics and drug distribution, neuronal dynamics. Immunology remains scarce. D to the root 2, it's your moment to shine. It's true underscore. So I didn't know that fractional order derivatives are somehow a little less local than regular derivatives. Weighted contributions from the entire history of the function through a power law memory kernel. I don't know what a power law memory kernel really means. But it seems... I don't know what it seems like. Can I see an example? Section snippets. Where are the fractional order derivatives? This is integer. Okay, so this is like the standard thing that they're modifying. So this is only integer derivatives. But what is this? So C is population densities at time t of cancer cells. S is cancer stem cells. T is cytotoxic T lymphocytes. M is myeloid-derived suppressor cells. Gamma is immunosuppressive cytokines. I don't know what most of those mean. But we have this integer order differential system. They got... Oh, no, they didn't get lazy. This is just the paper getting chopped off. And they chopped... Unfortunately, they chopped off the good part. Let me see if I can get this PDF. I'm probably not going to do a paper on this thing. Like, I don't want to mess with fractional derivatives. I am interested to see just what the differential equations look like, though. And I'm going to, in another window, I'm going to try and log in with my student account. Oh my god. And see if I can get access to the full thing. Ooh, I think I do have access. How do I download it? Oh, it does not describe to this. Never mind, I don't have access. Bruh. Oh well. Okay. Oh well. This paper, I feel like I've this paper is like, it's definitely a candidate for something to modify. What we could do, I have a few other papers queued up that we could look through, but I kind of want to switch gears and look at and do PDEs now. So this PD's homework is gonna be due on Thursday. It'd be nice to have it done sooner rather than later. Okay, so I want to go back to number 5. So someone in office hours made a comment that this is a 2-line problem. If you do it a certain way, and I think I've started the same way as that person did, but I was kind of fumbling with how to get the actual conclusion that I wanted. I was trying to do this on stream on Thursday. So yeah, there's kind of an issue where, so just to do the first part of the statement for this lower bound, I was trying to figure out, like, we want to take our generic domain omega and talk about a bigger domain that contains omega based on the diameter. That's my like blue circle down here. And then we need to define a function, and I couldn't figure out if I wanted to find the function on omega or on R. Or on D for the disk that I'm defining. Oh. So I think I originally tried to define the function on omega, but that was getting a little bit weird. I think I defined it instead primarily on D. Yeah, so I made F the out. Right, okay. So I was making F the optimal function on this blue circle that gives us exact equality with the Rayleigh quotient. And my idea was to rescale this F to be contained completely in omega in this green circle here. And that's what this F tilde is. Supposed to be, at least. It may not actually, if I did it wrong. And I was trying to just mess with F tilde to get a diameter of omega to pop out somehow. And that's what I was failing at. But I mean, this feels a little weird. Like, we should I go back to doing it the other order? I think I should, because this was getting really weird with the rescaling. Let me actually just make a new page. And I do want to copy a few things from this, like that. So let f be defined such that, oh god, the Rayleigh quotient it's going to be exactly, like this is the optimal f for the domain omega. And then we're going to extend f to the disk D just by using 0. And then we know lambda of omega is equal to integral f, which is the same thing that I already wrote once, squared dx, but it's also greater than, well, is equal to integral of d. I'm just going to say d, because I don't feel like writing this entire thing out every single time. And then, ooh, wait. Is this even what I want, though? What I really, really want? Oh, no worries, underscore. I respect you typing that out on your phone. You generally define fractional integration from base point B, from base point B, the intuition of a repeated classic integration. If you integrate n times f of x, you get a simplified expression via Fubini theorem to switch the order of integrals. In of f of x. Let's write this out. You integrate f of x n times. Simplified expression. Really? Wait, do they collapse into one integral is what you're saying? Oh, well, a fractional integral. And this x minus t is the weighted power kernel, I guess, is that the paper referenced. And extend this to real/complex values of n. Undefined fraction derivatives the operation undoes I of n. Yeah, I'm sure, like, from, like, should there be an upper bound here that's always staying the same? Or, like, I'm confused what the bounds are. Look at the Wikipedia page for fractional calculus right now. Leibniz was the first person to do it, apparently. Oh, yeah, okay. You were typing, yeah, if I were a LaTeX renderer, I would have made a pretty big mistake there. So this is part of the calculation. Yeah, this is the exact thing that you were just telling me under about underscore. Okay, so the first thing I was doing wrong was I wasn't thinking about dummy variables. The Cauchy formula for repeated integration. Huh. Really? I've never seen this before. It's a convolution. That's so weird. I can imagine, yeah, that this comes from Fubini. Use the gamma function to remove the discrete nature of the factorial function. Gives us a natural candidate for the applications. Yeah. It is in fact a well-defined operator. So if you compose, oh, that's a pretty nice formula for composition. It does exactly what you would want it to do. Okay. Speaking of crappy math notation, we have a before subscript and an after subscript. Like, what the hell, dude? Thank you, Fizzbuzz. Hope you're doing well. And thanks for the 3 streak. Find on Fourier series. Click on things Twitch tells me to. If there's a button Twitch provides you, you gotta click it. Oh my god. No. I'm zooming in on this. And I lost my place because I zoomed. Math has gone too far. Like, what is this? Atengana Balinu? You should be ashamed of yourselves. Co and contra variant notation, no subscript gang, just use parentheses. Yes, Milk. Hi, Jed. Wait, I don't know what I said that activated you. Ugh. God, this looks so dumb. Wait, is there... I guess you... The Laplace transform of a Caputo derivative. Okay, that's actually kind of wild. Fractional derivatives still have the same nice property for the Laplace transforms. Oh, the assistant of a deity! There we go. That's true. Yeah, Jed, I'm sorry for all the time that I've taken your name in vain. You are forgiven, my son. Thank you. You're a merciful God. Like, imagine left aligning a subscript that comes before. And gracious, don't forget that. Yeah. Very, very humble. The most humble. Oh, dude, this Wikipedia page gets progressively more disgusting the more you scroll down. Now go forth and sign no more. Okay, that's a good one. I co-sign that. The French page is less dense. I guess I should learn French. Let's see, I just want to see what the applications are. Fractional conservation of mass. Needs model fluid flow when the control volume is not large enough compared to the scale of heterogeneity. And the flux within the control volume is non-linear. Really? Neopolarogram. Electrochemical analysis. The Laplace transform of Fick's second law. The solution contains a 1/2 power dependence on S. What the hell? Apparently, this has more uses than I thought it did. A piezometric head? They're just making up words now. Time-space fractional diffusion equation models. That's probably related to what we've already read about. But the heat equation in fractional derivatives is apparently a thing. Ooh. The negative sign is inside of the beta. Do fractional derivatives not have, like, are they not linear? Like, we can't take the negative outside? Oh, I can see this for PID controllers. Halo Aquilo, thank you for the follow. Fractional Schrodinger equation. Okay. I think that's all I can take of fractional calculus. Hello, Halo. Welcome in. How's it going? Oh, I'm sorry. Talk about math making up words like it's a new concept. That's true, Jed. Yeah. I don't know where math people get half the words from. Logarithmic equation? If you want, feel free to hit me with it. If you can fit it there in chat, feel free to type it there. Or if it's easier to put a screenshot, you can put it in my Discord. Yeah, no worries. We haven't shown anything about the scaling previously, have we? I mean, it should just be a repeat of number one. Like, um, this has an inverse power of r squared. Um, yeah. Okay, so sent it. I see. Ooh, that's an interesting one. Log squared plus Spotify Doors channel? No, it's just radio for Riders on the Storm by the Doors. So that's why there's been a lot of Doors, I guess. This looks so. The thing that I'm noticing with this equation is that the log base 5 of x is kind of like these two things are the same. Like I could, it might look a little bit nicer if I said, like, let's just say Benelux already has it. Log what I'm just gonna invent a new letter y that is log base 5 of x, and I could rewrite this equation as y squared plus 2y equals 0. And this is something that you might be more comfortable with knowing how to solve, where you just factor out a y, and then you would split it off into two separate problems. So one would be y equals 0, the other one is y plus 2 equals 0. And we're getting two solutions. So either y equals 0 or y is negative 2. And then we can remember, like we said, y is this. So let's go back and actually plug in the log base 5 of x in, because we want x. So from this equation, we know log base 5 of x could equal 0. And from this equation, we know log base 5 of x could equal negative 2. And we isolate x here by doing 5 to the power of each side. That's how you undo logarithms, by taking powers. So on the left side, this cancels, leaving just x. And then on the right side, 5 to the 0 is just 1. Hey, Skirtle. Same here. That cancels, leaving just x. And then this is 5 to the power of negative 2. Sorry, I should have like slowed down. That's 5 to the 0, which equals 1. This is 5 to the negative 2, which is like 1 over 5 squared, which is 1 over 25. Thank you for recognizing me for being a princess. I'm missing a square on the left term. I don't think so. Like, you mean over here, Jed? So this came from, like, this equation, like, after I already factored it. The answer is correct? Okay. See, I was about to, like, sometimes these logarithms are a little bit weird. So it is good to, like, plug these numbers back in. I don't think there can be any weirdness here, but log of 1 is always 0. So actually, yeah, x equals 1 works. And 1 over 25, it's negative 2 squared plus 2 times negative 2. So yeah, I think that works. Only partial credit for Femvox. Yep, half credit at best. So yeah, Halo, this is a common trick that they'll pull on you. Like, it's just a quadratic equation at its heart. They'll sometimes do the same thing with, like, sines or cosines, or like even exponential functions too. But at the end of the day, if you have, like, as long as the bases are all the same, like, you have something squared plus something, it's still quadratic. Yeah, let me know if you have any other questions, Halo. And so I see that you're new around here. I do like to let new people know that this niche exists here on Twitch. It's not just me who does math streams, and that's those people that I kind of, like, generally recommend, but there's many more streamers than just that. So if I'm ever not around and you need help with something, like, yeah, it's a lot. So I'm not saying, like, hit follow on every last person on the list unless you want to. But yeah, our niche has been growing slowly, and that's my goal. I want to try and grow our niche, so that's why the list is so long. But yeah, like, people who are, like, the people on the list kind of go through phases of streaming more or less than each other. People who are, like, especially active right now are Actual Education, Ian Stuckey, E to the Toy Pie, and Simplex Pachinko. So if you only followed a few people, those are the ones who are streaming the most recently. And I'll write their names separately. Simulating techniques solve like it's the fourth. Oh, true. Yeah, yeah. Daryl Hall. Oh, is this Hall and Oates? It is. Maneater. I forget why, but Hall and Oates always reminds me of being a kid and playing Roblox, because one of my friends on Roblox really liked the song Private Eyes. And so whenever I think of Hall Notes, I think of that song and I think of like my Roblox days. Kiss on My List? I don't think I've heard that one. Let me put it in queue. Kiss on My List. It will play after this song. They're accused of Garfunkel and Oates. Is that real? It's a comedy duo. They're not family friendly. That's not a problem for me. There is a fly on your nose. You should really swat that thing away, Skirtle. That sounds kind of gross. Kate McCucci? No, that sounds like a prank name, to be honest. Sounds good, Halo. I'll probably be going for another hour or so. So yeah, and you're going to post things in the Discord while I'm off stream too. I might not get to it immediately, but I'll write you a response. Lucas, hello, and Serene Salt. Thank you for the kind words. Oh, you're seeing the partial derivatives earlier? I think I've erased them now. Yeah, I erased them. Yeah, I was interested in learning a little bit more about them because I happened to find a paper that applies partial derivatives to cancer modeling, and I never knew that partial differential equations, or that, sorry, partial differential equations, that partial, oh wait, I'm sorry, partial, oh my god. My brain is not working. Partial derivatives. Okay. I had a major brain fart. I got partial derivatives mixed up with fractional derivatives. Yes, partial differential equations is what's on the screen right now. Well, this is there's not an actual partial differential equation on the screen, but this is homework from partial differential equations class, and is related to partial differential equations. God. But yes, Serene Salt. For background, I'm an applied math master's student. I'm currently in a partial differential equations class. This is homework from that class. That's one of the duo that makes sense. It's on, not in. Yeah, I mean, but you shouldn't. You should swat it away. Is what I'm saying. Don't just let it hang out there. It's a real name. Oh, okay. No, Ian Stuckey has named that because that's just the initials of their name. Sounds good. Hey, Halo. We continue with my division by zero thingy. I've had like one difficult algebra made that combines multiple groups. Oh, okay. This is after differential equations or before. So yeah, you're talking about like I assume when you say differential equations, you're talking about like ordinary differential equations, which are normally the first thing that the first type of differential equation that you learn about in like a differential equations class. So partial differential equations are definitely after ordinary differential equations. They're usually, or not, I can't say usually, but um, you can sometimes take a partial differential equation and turn it into multiple ordinary differential equations. So for that reason, you want to understand ordinary differential equations first. In fact, if we can solve a PDE, it's because we can make it into an ODE. Usually there's no other way of solving it. Besides guessing. How equation might be silly. Have you heard of conditional state equations? Not by that name. Let me Google them. Are you talking about like probability? Maybe this is it. Sure. If it's just stuff like this, I know what this is. If we to say what your actual question is. I'm not sure if I'm thinking of the right thing though. It's a semi-associative group. Ooh, okay. Where 0 times A equals omega. And A equals B plus C times L plus D times omega. 0 times C times L equals 0 times L times C equals 0 times L times C equals omega C, kind of giving up the idea of making it anywhere. So it looks like it's commutative also. I'm not sure what capital L is. It has all the properties. Okay. You don't know if they're based on Boolean decisions, CSE. So I guess Serene Salt, is what's on the screen a conditional state equation as you're like thinking of? Like, are these examples of what you're talking about? You guess? So if you just have an equation that is only true under certain conditions, I guess you could call that a Boolean decision. Like your condition is either true or false. Um, I feel like I'm not. I feel like there's something here that I'm probably missing though. Um, at some points another thing came up, the x minus x equals k, and omega squared equals k, and L squared equals 1. Came way too strange. You had Claude look at it way better than Chat GPT. Yeah, I mean, if it starts complimenting you a lot, I wouldn't give it too much credence because AI tends to do that. But I get that it's nice to have like a study buddy. This looks like it might be it. Decision-based systems rely on Boolean algebra. Well, this is a lot of notation. This might not be it. um, Yeah, because I think you could, like, like some sort of like piecewise equation like this, you could reformulate it as one equation involving like Boolean variables that are 0 if they're true and, or sorry, that are 1 if they're true and 0 if they're false. But again, I'm not sure if I'm getting at what you're actually asking about. So I'm sorry if I'm not understanding you. Plus, makes the ordinary mistakes ChatGPT makes. He knows how to formulate something better and can spot inconsistencies way better. Okay, fair enough. Equations or functions are deterministic. Well, deterministic to me means not random, and nothing that we've done so far has any like randomness involved. All right, see you, Lucas. Thanks for sharing. So I'm not sure if you mean deterministic in some other sense. Serene Salt. Probably not, Fembox. It would be cool to, I mean, it depends when exactly it starts, but as for, I think I saw him saying that the first like week or two will be fluid dynamics, and that could be cool to at least loosely follow. I saw the actual like E&M portion. It's not gonna get like, it doesn't seem like it's a really short class. Like they can't get super deep into it. And like the part of E&M that I really liked was like the special relativity stuff from Purcell's book. And like magnetism. And I think Dr. Gold can only go so far as like, or I guess like not magnetism, but like Maxwell's equations in general. And I don't think Dr. Gold's class is able to get there. It is fun to set up those integrals. Like just like I did really also like just like the early days of setting up like the Coulomb's law integrals too. So I probably would still enjoy it for that reason, but it's like, I don't know, it feels like it. I kind of already feel comfortable with a lot of the parts of E&M that I think he's going to be covering. Have the algebra done on this live stream deterministic? I think so. Serene? Like I haven't done anything with probability. Everything's deterministic. I know the next thing you're gonna say. Oh yeah? All traders insider trading? Floppy, you know all and you see all. I'm doing good. How about you? In literal terms, I know everything. I wouldn't doubt Floppy. I'm a Floppy believer. Doing all right. Good to hear. I mean, you're omniscient, so I hope you're doing all right. 10 to the power of 3 can be written as root 3 of 10. No, as Penblock says, the roots only come in if you have a fraction. 10 cubed is just 10 cubed. Oh, minus 3. Okay, that's different. So it's not a root. 10 to the minus 3, the entire thing becomes like, you flip the entire thing, so it's 1 over 10 to the 3. Yes, Serene Salt. Fluffy's just joking around. I already knew you because I know everything. The roots come in if you had 10 to the 1/3. That's the third root of 10. The answer should be root 3 of 10. There must be a typo in the question. Because these are just two different numbers. Yeah, cube root. That's what I should be saying. 3 log squared x minus log x equals 0. Move my head to the wrong side. Square root. Oh, okay. I had no worries about the translation. Let's scroll down. I assume, are these base 10 log? Yeah, they must be base 10 if that's what you were doing. Okay, so yeah, I won't do the y thing this time. I'm just going to directly factor this. Like this. So we either get log x equals 0 or 3 log x minus 1 equals 0. Okay, so yeah, I can see where you probably went wrong. The left equation is the quote-unquote easier one. This is just 10 to the 0, which is 1. But the right side is the more interesting one, which is where the confusion came from. So why the minus 1? Okay, so that's this minus 1 here came from factoring just one logarithm from these two terms. So this is a log squared, so there's a 1 log left over, but this is just a minus log. So when I take the log out, it becomes a minus 1. And if it makes you more comfortable, we could do the same thing as before, where we say like y equals log x. Oh, okay, that sounds like that you're on board with it now, so I won't do that. The 3 can power... I would rearrange this equation before taking the power of anything. You could take the power of 10 right now, but it'll be more complicated. Weird proper differentiation? I gotta think about that. Let me keep going through this, and then I'll think about it more. So on this equation, I would add the 1 to the other side first. And then I would divide the 3 over also, just to isolate this log. And now do 10 to the power of each side. So you get x equals 10 to the 1/3. And that's the cube root of 10. So I think your mistake was you somehow ended up with a negative 3 here when it should have been a 1/3. And so yeah, if you did 10 to the power of this equation, you should still get the same answer, but it's more complicated to get it. Yeah, logarithms do have great properties. Okay, and so I think the weirdest property of differentiation, I think, is the chain rule. Like, I kind of take it like it's easy to take for granted when you first like learn about it in a calculus class. The minus 1. Oh, okay. Yeah, it's kind of strange that like that's the rule that we use because of for composition. And with multiple variables, it gets 10 times weirder. So I tend to struggle with the chain rule with multiple variables. Oh, the quotient rule is also, it's annoying. I don't know if I would call it weird. Here's one for you is the mean value theorem. Oh, I think that, to me, that one's cool instead of freaky. I don't think I've heard this song before. Ghost song, Jim Morrison, The Doors. No, I haven't heard it. It's both for you? That's fair, Fluffy. Vision, you often don't straight answers in chain rule? I don't know what you mean by that, Serene Salt. I'm taking a screenshot of what's on the screen right now because I want to use it for number 5. The result of expressive variable like x or y. Yeah, I'm still not sure where you're going with that, Serene Salt. I'm sorry. Darboux lemma. I don't know if I know the Darboux lemma. Darboux ligma. Probably this one down here. Every function that results from the differentiation of another function has the intermediate value property. The image of an interval is also an interval. I think it's like the topology version. Why is this surprising? Even when f prime is not continuous. Okay, that's the surprising part. If f prime is not continuous. Because if it's a smooth function, I would think this really isn't saying anything at all. Like, nothing new that would mean the intermediate value probably doesn't already say. That is kind of freaky. This is a good answer, Flofi. Yeah, I guess, but like C1 is the most interesting case, I guess. Yeah, I do proofs and induction. It's not my strong suit, but I can do them. C1 is obvious. Oh, right. Or I'm getting confused on the directions. Because, like, you're coming from F prime for Darboux's theorem. Their functions that are differentiable and the derivative is not continuous. Really? Is it differentiable, like, piecewise differentiable? That's the only way I can imagine that's true. Like, just a, well, yeah. Not even a C function, but I know about piecewise functions, serene salt, yeah. I use them a lot. The weather, it's been kind of strange, Fembox. Uh, it's been like kind of hot and cold, literally. Some days are getting as high as the 80s, other days are still like the highest in the 60s. And I feel like I am terribly suited for every type of weather now. Like I come from California, that's a lot hotter than here. But even on like the maybe 2 days we've had that have gone into the 80s, I've been like boiling and like dying of heat. But on days that are in the 60s, I'm dying of the cold. So I I feel like I'm not acclimated to any type of weather and anymore. I'm just always like suffering. We're supposed to get rain next week too. Or this yeah, like Wednesday through Saturday. But yeah, so like for next week it's gonna be in the highs are in like the 60s. Highs in the low 50s in May still? Wow. Differentiable everywhere, its derivative is not continuous. Oh yeah, I've seen this before. Yeah, I've read that everyone believes these are called like topologist sine curves or something like that. Lows in the high 40s. Oh yeah, let's see what my lows are. My lows are like high 40s, low 50s. I hope the summers here don't get too bad. So that'll be annoying if they do. 33 Celsius? Isn't that really hot? 33 C to F. 91 degrees? Oh god. $91 American degrees. 58. Oh, are you somewhere tropical? I'm not a fan of hot weather. Oh, okay, that makes sense. Floppy. And I've lived in Hawaii too, so I know tropical weather. Thank you, Yanis. Hope you're doing well. Oh yeah, E2 Pi slash Zach was just streaming a few hours ago. He raided into me. And yeah, this is my first and potentially only summer. Thank you, Peach Tea. So yeah, I moved here in August of last year, so like the tail end of summer. And it was decently hot then, I think in like the 80s. I did hear back from my landlord, and I'll be able to extend my lease for a few months. He said I can extend for as long as I want. I only want to extend it for a few months. So because like it's currently gonna end at the end of July, and I graduate in mid-June, so that would be very little time for job hunting. So I'm gonna try to like stick around up here, but depends whether I can like find a job and support myself up here. This one's at 100% humidity when I was a kid. Jeez, that's a lot. That's a lot of humidities. Um, get tenured. When I get tenured, please finesse me in nepo position. What me? I can't even get them to accept me as a PhD student. Like, you're gonna be waiting for a long time. Target kind of position? I still don't know, Zach. It'd be cool to teach at a community college. Um, Short of that, though, probably like some sort of like uh um like it'd be cool to do some sort of like biomath like research type of thing. You take a nepo job too. All right, I'm making a list. If anyone wants a nepo job, just let me know. So like you may have seen on like Science Stream um he's had sorry, I don't know why I'm struggling for words right now. People from the Fred Hutch Cancer Center present there. And the Fred Hutch Cancer Center is actually located here in Seattle. My math bio professor last quarter actually like works there, and so that could be like a cool place. I don't know what type of jobs they actually have, but um, they do a lot of like medical research type stuff. It seems so that'd be cool. Um, yeah, I really haven't put too much thought into it. When I cure cancer, remember my Twitch day ones. Oh God, Wolfie, you have. Thank you for having so much faith in me. I think it's misplaced, but thank you. um. Oh wait, you know what? Uh, Maybe we'll keep the definition of F. Wait, okay, no. Let me just. I want to chop this off it entirely. Let me get rid of all this. Is there Dawn merch we can get before it skyrockets? Yeah, you're gonna see like OG merchandise up for sale on eBay going for thousands of dollars. No, I like there are actually services that make it really easy for streamers to put out merch. Like you can be a really small streamer and have merch, but I feel like I don't know what kind of merch I would make. And I also can't imagine that I would like actually be able to sell much any of it. So it doesn't seem worth the effort. Sure, the cheesy math puns, Bibs. You know, maybe you're on to something. Like I definitely wouldn't want like a shirt that's just like a big old like Dawn factorial on the chest or something, because like I feel like that I personally would not wear a shirt like that in public. Cliff Stoll, I don't know who that is. Sells Klein bottles. Pick another compact manifold. Sell it made of glass. It's true. Klein bottles are pretty fun. Too much room. Richard has their name and logo on it. Seems weird to wear it outside the house. Yeah. Kleinbottle.com. I did not know this website exists. I gotta see what's on it. Oh, this is... This is... Oh my god. This is the website of someone who just learned HTML yesterday. Oh my god. Oh, this is... Oh, this is the perfect website. Cliffstone in Oakland, 2 blocks from Berkeley, 10 kilometers east of San Francisco, epsilon away from some boundary. Oh my god. My camera quality is peak. Thank you, thank you. Yeah, I think a lot of websites are needlessly fancy. Oh my god. Kleinbottle AATT kleinbottled.com. he's oh my god. That's like some old-fashioned technique to make it so bots can't automatically scan your website and add your email to mailing lists. Oh my god. Yeah, that's true. God, this website is so funny. A Klein bottle hat. There's an M&M Klein bottle. Like, guessing how many M&Ms are inside the Klein bottle or outside the Klein bottle, depending on your persuasion. Erlenmeyer Klein bottles. Oh, this is so useful for storing liquids. It was there? Oh. Let me... M&M. Oh, yeah. We missed out. Another summertime time waster. How many items fit into a Klein bottle? Hey, this is a packing problem. It's like a not quite a spherical packing problem, but whatever you would call the shape of an M&M. These Klein bottles have 0 volume, and they're one-sided. The answer is 547 M&Ms. There are a couple of infinities. I mean, that's kind of true. I kind of like infinity as an answer. Because, like, what is in a Klein bottle? Yeah, as Jed is saying. Like, I feel like all in the world infinity is actually kind of correct. This was in 2001! Oh my god! Look, like, it's 2001, he just never updated this. This is such a good website. As of September 20th, about 8 people have entered. I haven't looked at the entries yet. I wonder if he has 25 years later. I bet the answer is no. Okay, this is the winning answer. It's like an ellipsoid? Yeah, I guess so. You were 7? In 2001, I was 4. Empirical measurement of M&Ms contained in standard bottom mouth Erlenmeyer Klein flask comparison to theoretical models. Bernard Tao? Related to Terence Tao? Question mark? My voice is going high? Department of Useless Information in an effort to win free Klein flasks? Large Midwestern University somewhere in soybean / corn belt. Oh my god. This is solely for obtaining such a flask absolutely free of charge, either with or without M&Ms. This might be my new favorite website. Oh my god. The objectives of work was to obtain a completely free Erlenmeyer flask as noted in 4. However, if available, completely free Kleinstein of similar volume 5 would be preferable. Don't forget to pick this up too. KleinTools.com. There's multiple Klein domains. This is for opening Klein bottles? Oh my god. Wait, does it have a Klein bottle inside of it? Or like, what makes this Klein? Is Klein just a brand name? I think this Klein is just a brand name. Yeah, okay. That's what I wanted. That's a Klein bottle opener. Well, I guess there's two interpretations. It could be something that opens a Klein bottle, which I guess would just be a hammer. Or it could be a Klein bottle that opens regular bottles. This is such a funny thing to have. It doesn't look like it's for sale though. This is just like for display purposes. Oh wait, there's a cart. What else is on this? Huh. This makes me uncomfortable to look at. I don't know why. This reminds me of these like metal puzzles that I would play with as a kid, where you had to like disassemble them. Trypophobia? I guess so. Yeah, the fear of lots of small holes. This one is okay though, and like this one too. It's just the 120 cell. I have a fear of the number 120, maybe. Pages now mainly galleries. Tech using to make these has been sunsetted without replacement. Rest in peace. Boromine? What is that? Is that a Tolkien character? These things? I don't know. On the original page, do you happen to see the double and triple Klein bottles? No? I assume these. Oh, hey. 250 to or $350. Whoa! Okay, these are cool. Which is a Klein bottle and which is not? A Klein noddle? Which one? Really? One of these is a Klein bottle, the other isn't? How do you feel about infinitely fractally dense Swiss cheese? I would need to see it to answer that question, I think. Like the three rings where no two are actually linked, but all three are linked. Oh, that's weird, Peach Tea. In the bottle opener page? Oh, for... Okay. I'll look at that in a second. Leave it to you to figure out which one is the real Klein bottle. The double Klein bottle looks like an hourglass will it work as one. The wine Klein? You can store wine in it and pour wine into and out of it. It's not very practical as a wine carafe. At least he's honest. Oh, because you would have to, like... You want to hold it with this thing, but I think you'd have to... Like, you'd have to have it upside down to pour wine out of it. Probably. The giant Klein bottle is 18K? Oh, you're right! How... Oh, this is... Oh my god. 18,000. For non-scientists. So that's with a 5-year-old child. A ferret can climb into it. Wait. Please tell me he has a ferret. This guy seems like the type of person who would have a ferret. Ooh, that's a cool picture. I'm scrolling for... I'm looking for a ferret picture. There's a disturbing lack of ferrets on this page. Oh well. So wait, what was... Bibbs was saying the boromine in the bottle opener page. Oh, this one. Okay, yeah. That's fair. That is a lot of small holes. A mathematician named Klein thought the Mobius loop was divine. Said he, if you glue the edges of two, you get a weird bottle like mine. Jed with the poetry. I love it. That's so good, actually. Got me intrigued with the question of what kind of geometric object an M&M will be. Rotational solid of a lens-shaped region. Oh yeah. Take the rotational solid along the major axis. The name for it is a lemon. Huh. The surface resolution of the complementary arc of the same circle through the same axis is called an apple. Yeah, I think I can see the difference in the axis. I think. Well, yeah, I mean, these are mathematicians. They're not gonna name something after a football. Like that's sports. We're too nerdy for that. Actually, a football, it does exist in math. It's just a different type of thing. North American football? Do Canadians not do Canadians say soccer? I assume that they said football for soccer. I feel like I mean, like Mexico definitely doesn't. I don't know. I'm get North American football. Like the North in this caption is what's like messing with me. I don't know. What's up with the Boromir rings? Thank you, Syntax. Oh my god. These words aren't making any sense to me. I'm clicking off this page. Is there anything else that's cool on this page? Question mark Klein bottle. That's kind of abstract. Eh. Oh, I guess, okay, the question mark is like just this thin one. I guess that's fair. Kleinstein. Whoa. Oh, they have a schematic and everything. This cheesy, oh, cheesy with a Z. Oh my god. This is hilarious. Mobius scarf. Okay. I I could spend forever on this website. I think we gotta click off it though. Ugh. That's a fun rabbit hole though. It is. That website is so perfect. You don't. That's true. I don't have to. I could spend all day if I wanted to. Yeah, Flofi. I love those websites that are like fighting the good fight still. Um, in terms of like not being overly fancy. Like I love that Craigslist has not changed. There's a local restaurant here in Seattle that has a website like that. I can't remember which restaurant it is though, unfortunately. It might be a pizza restaurant, but it's a website a lot like that. We can get very immersed in clam bottles, but in trying to get out, you realize you already were. You make a good point, Jed. I'm still appreciating the cleverness of the how many items can fit inside of a Klein bottle question. Like, I think the answer should be infinity. Like, as many as you want. Or 0. It shouldn't be a finite... Or it shouldn't be... It should be one of those two things, though. Dinos, yes! Wow, you found that fast. Yeah, this is it. Oh, that's so good. Because I didn't end up going here, but I was thinking about going here a few months ago when I was looking for a pizza place. Wait, is it? Maybe I was thinking. No, I mean, I was thinking of a different place to go to. Maybe I don't think it was there. I don't know. This website is still amazing, though. The site is best viewed with Netscape. Oh my god. This link leads to DinosTomatoesPie.com/Netscape 4.7.2.zip. It's not even like Netscape's website, if they even have a website still. Ugh. Hey, yes. So that's a great name. Biscuit Bitch. Oh yeah, Jed, it's over that one you showed me before, like Dirty Dick's Crabs or something. Be a shop bitch. Be a bitch jobs. Ugh. That's funny. Biscuit one doesn't see. Oh, really? This place, it kind of sounds good. Dick's Pizza. Oh, Pike Place. Or in Belltown. Okay. Usually Pike, like, the restaurants in Pike Place are usually pretty freaking expensive. Bitch witches? Ugh. I wonder where in Pike Place they are, because I've walked around it a fair bit. And I don't remember seeing it. Zombie Jesus? For Penn Center stream? Oh, really? Oh, okay. I didn't realize he had a story about Dick's Pizza. It's a cultural staple. Okay. Okay. I was planning to end my stream about when Zach goes on Shane's stream, and I think that's just started. You'll see almost immediately. Okay. It's been hard for me to catch Penn Center streams because he's been telling me to stream while I've been in class, but hopefully I can catch him sometime when he's back from vacation. Let me just make sure that they are live. I think I just saw the ping. Thank you for being here, Bibs. If you're interested in math stuff in general, which you may or may not be, I'm not the only one who does this. There's a whole like niche here on Twitch. I don't know either. I don't remember your name. Your follow date since 2024, July 26th. That's a long time. I I do also play games. Like it, if you watch DayZ, you may have found me through a raid. Um. Oh, from Ben. Yeah, Ben's awesome. Yeah, he's rated me a few times. I've got to ask how his studies are going. So I think he just like transferred universities. Yeah, yeah. For a while, we were trading. Like I was helping him with his math classes, and he was giving me surf coaching. Okay. Yeah, it was fun times. I do think that's going to be the end of it for today. I want to go support Zach. I'm also getting a little bit tired from thinking about math for so long. Um, so yeah, I'm gonna cut the YouTube stream off here. So anyone here on YouTube, thanks for being here.